Imagine a high-stakes baking competition where contestants get exactly 1 hour, a single set of ingredients, and absolutely zero chances for a do-over. We're putting 4 of the world's most famous artificial intelligence models into this exact scenario. Our contestants are Claude, GPT, Gemini, and Grok. Instead of baking cakes, they're building complete interactive web applications. And we aren't writing a single line of code ourselves. We're just giving them a simple recipe prompt, like build a playable video game. Some of these tasks were incredibly complex, like creating a 3D rocket launch from scratch, complete with ignition, heavy smoke, and a slow, steady liftoff that speeds up as it climbs. Others were asked to create interactive fireworks, where every click on the screen creates vibrant explosions that react to gravity and drag. But the experiment followed a strict one-shot rule. Our AI chefs got exactly 1 chance to generate the entire file. No fixing bugs and no telling the AI to try again if it glitched. Whatever it served up first was the final result. When tech companies show off these models, they usually show you perfectly rehearsed demonstrations. We wanted to see what actually happens when a regular person uses the public chat box on their laptop. Finding out which AI can actually deliver a working product on the very first try matters. It saves the rest of us from spending hours trying to fix broken code. Over 8 weeks, we ran 17 different bake-offs. That gave us 68 different web applications to test, use, and score. One model consistently pulled ahead of the rest. Across the entire study, the Claude family delivered the highest quality, most reliable web apps on the very first try. Now, you might assume that the AI taking the longest time to think about the problem would naturally bake the best cake. This chart compares reasoning time versus the final performance score. Look at the contrast. One model thought for 11 seconds and delivered a near-perfect app. Another thought for 23 seconds, twice as long, but produced a broken simulation barely scoring 0. A long loading bar can look impressive, but just because an AI is spinning its wheels doesn't mean it's actually building you a better product. We also noticed a massive difference in how much code these models wrote. Some would solve a problem with a few hundred lines, while others would write thousands of lines for the exact same task. We wanted to know, does an AI write a massive wall of code because your instructions were long and complex, or does the AI just like to overcomplicate things? We tested which factor predicted the code's length, the prompt's word count, or the model's identity. The specific model family was the winner by a mile. Prompt length hardly mattered. Some AIs are just wordy overbakers by nature. If an AI dumps 1,000 lines of code on you when a fraction of that would do, you didn't write a bad prompt. You just hired a chef who uses way too many ingredients. Once these apps are built, we face one final hurdle. How do you objectively judge a game or 3D simulation? We used a dual grading system for every single application. They faced a blind test by a human expert and an AI guest judge named Gemini. This chart compares their scores. Notice the massive gap in how well the code actually worked. The AI judge was way more lenient, giving scores a full point higher. We must be careful when AIs grade their own homework. This bake-off gives us 3 clear takeaways. First, Claude is currently the best at the one-shot test. Second, long thinking times are often a myth. And third, AI judges can be far too forgiving. These tools are incredibly powerful and ready to use today. You just have to know which chef to pick and give them clear instructions. AI mixes the ingredients and bakes the cake in seconds,